project to product. Is that right?
Yes.
So let us see what is the difference between project and product. When we do project in the engineering college, what are the objectives? If we look at that objective, look at the objectives of the project, basic objective of the project is to explore, to understand, try, then maybe to create, innovate. So the outcome of the project is understanding, then maybe a proof of concept or a functional prototype or problem definition or some kind of analysis, some kind of um, creation of a framework of design or methodology of design. Because when we are doing a project, we understand how we are supposed to be designing that particular um, project we are doing, we are creating. So we study that topic and we try to develop a document, a paper or a report. And if you look at the product, the objective of the process of making a product is different. It's not same as doing the project. In product, we are synthesizing and developing a capability to reproduce any particular model. So whatever concept proof that we have got, proof of concept, prototype or a lab level initial prototype. Instead of that, we would like to, am I audible? You send it by mail to me so that I can open here on the laptop, on the mobile. Just send it to me by mail. Just send that. I have to 1 minute. I'm my laptop probably is working now, so I may be able to log in from there. Can you type the Zoom meeting code?
Okay, sir.
No, link is in WhatsApp. I mean, I will send the link by mail. Just see the mail. Okay, am I audible now?
Yes, sir.
Can I share? I will share a screen.
Yes, sir. We are sharing this.
Okay, is my screen visible?
Yes, yes, there is.
Okay, so coming back to our topic, project to product and specifically work planning in that. Now, if you look at the uh, 1 minute,
F5. Press F5, sir.
is it visible?
Press F5.
No.
Thanks. Hello, am I audible, sir?
Good afternoon. Is it now visible?
Yes, sir, it is.
Okay, thank you. Coming back to our main topic, project to product and specifically work planning in that. How do I go to the next slide? Where did you click? Here? In project, the objective is to explore and learn, innovate, create product, and the outcomes are paper or a report or a proof of concept, a functional prototype, and understanding. Whereas in product, the objective is design and synthesize or create document, create process, the methodology, work out the costing, work out some kind of a business plan, then only the product will come into reality. And what is the outcome? The outcomes are manufacturing drawings, which are very detailed, dimensioned, authentic description of the mechanical, electrical, electronic, software. All these are called technical documents or drawings. So a software doesn't have the same shape as a mechanical drawing, but nevertheless, a well-documented software will have a unique identity, will be given a number, and it will be preserved as a record to be referred to. So that is also called as a drawing in the engineering language. So the drawing may be a mechanical drawing, electrical drawing, which is say a wiring diagram, or an electronic circuit diagram, or a PCB, printed circuit board, or it could be an assembly drawing showing different parts fitting into each other, or it could be a documented software. Then there are, in the outcomes, you have process plans. Process plans are a description of a process, a method by which that product is to be physically made or assembled from materials and parts fitting into each other, how the product is to be made. Then there are quality plans. Quality plans are description of the inspection checklist, what to check, what to inspect, and what to expect as a quality, and what is a tolerance band, so that if the product is not within that tolerance band, it will be rejected. So acceptance and rejection criteria are known for each and every characteristics of a product. So for example, if your project is to make one plastic box or something like this, then the dimensions of this box in terms of length, width, the roundness, all these have to be inspected when you actually make this. If there is any defect in the molding, the dimensions may be distorted, and in that case, that product is not what it is supposed to be. It is different. So all these details are in the quality plans. Then you have tooling. As a project, we designed a box, a dispenser box for the tablet. But in order to make it, you have to make a plastic mold for the cover and for the bottom. And you have to make something by which this product will be manufactured. That is called tooling. If it is electronic PCB, then you have to make the PCB layout, and then from that you have to make the Gerber files, and you have to make actual optical masks for manufacturing process of that PCB. That is called tooling. So you have to have tool design. The tooling is designed for the quantities to be produced. Suppose you have to make 10,000 these boxes, then you require a tool of a material which will last for 10,000 impressions or 10,000 times molding. So there are properties of the tools, there is a cost for the tool, and there is a method by which you do the tool design. Creating a tooling is a part of a product. Without tools, you cannot manufacture the product. Then you have, am I audible? Hello?
Yes, yes, you are audible.
Okay, then there is a final manufactured prototype. Using the tool, you make actual final prototype. That is a first article or a first model, first output from the tooling and from the process, which can be considered as a final prototype. And this again, you have to test. You have to measure the functionalities, the dimensions, the quality as per the quality plan. Or you may make a pilot batch. You might make something like 50 such boxes, so that if there is any piece-to-piece variation, even that will be understood, will be visible. Then you have documentation for production. Documentation for production has many things like all the other things like drawings, process plans, quality plans that we have seen. In addition to that, there is time required for production. In case you have to plan 100 pieces, how much time will be required? What resources will be required? What will be the layout for production shop floor where you will produce that product? All these details are also part of a production documentation. Then you have to have test reports and certificates. Whatever prototype or pilot batch product you have made and you have inspected, you have to test the product. For example, we have made this box and we have to test it for the strength. So we will put a load on this. Suppose it is supposed to withstand 100 kg load. Then we, as per design, then we will load it with 100 and see that it does not break. Or if the method of testing is to heat it to 50 degrees, 55 degrees centigrade, because it is supposed to withstand that as part of our requirement specification. Then we will test it by putting it in the oven, increasing the environmental temperature to 50 or 55, and then examine whether it has been deformed or melted or burnt. So there'll be test reports. Now, when you do testing, to convince the customers that you have done the testing of the product as per a certain standard like BIS or UL or CE or IEC or ISO, you have to create, we have to obtain a certificate from a proper agency which is authorized to give that certificate, who will say that yes, this product was tested as per standard numbers and so, and it has been found to perform satisfactorily. So those certificates have very high value. When you want to take the product further, without the certificates, people may not accept your product. Then you have to generate training documentation. There are different kinds of training you have to do. You have to train the production people, you have to train the users, you have to train the servicing engineers or technicians about maintenance or repairs of the product. So all the documentation required for conducting the training is also to be produced when you are thinking of a product. Then there is a user documentation. User documentation is related to common man who may not know anything technical about the product. So that person will look at the product as a user. So there what you need to do is only describe what is externally visible, what is relevant and significant in terms of actual operation or actual usage of that product. So that documentation, maybe it is required in multiple languages. Maybe it is required so that children can understand it. Maybe it is required in a specific method which is used for training of the users. Like for example, if you're making something from a military or army, they have certain way of writing these manuals, user manuals, and you have to follow those methods or those formats. So this is user documentation. So these are the differences between a project and a product. So when we are talking of from project to product, we need to have resources. For carrying out your project, many times these resources are required, but often this may not be as sort of as essential as it is required for product. And for the project, for example, instead of computer-aided design software, you could do design by hand calculations, and you may not need to generate very exact or accurate results. Approximate designs may be good enough for doing a trial or making a first prototype. So CAD and CAE software, computer-aided design and computer-aided engineering. Computer-aided engineering means analysis. So you do a design and software level testing of the performance of the product or the dimensions of the product, strength of the product by using the simulation. Then you require tool design software. As we said, one of the outcomes at the product level is tooling. So you have to have a designing software for designing those tools. For example, if you are going to produce printed circuit board by using layout software, you require software for doing the layout, for editing the project, for modifying it in case any changes are required, and so on. So you require appropriate PCB design software. Or if you are doing the plastic injection mold, then you require a mold design software. Then you require documentation software for diagrams. You may have to prepare diagrams to illustrate the point in terms of, let's say, flow chart or the structure diagram or a kind of a checklist, and you require some software so that you can prepare it in a proper format. You will require a workshop to carry out the actual machine operations for manufacturing a prototype. You will require test facilities with calibration from accredited laboratories. For example, if you are doing testing of, let us say, operating, let's say, temperature. Now, if you use any thermometer for measuring the temperature, if you measure by another thermometer, it may show different reading. And in that case, which thermometer is to be believed? So in all this testing and measurement, the measuring instruments that we use, they have to be calibrated periodically, and you have to be able to verify that the calibration is done by a laboratory which is authorized to do it, and the instruments that they use for calibration are themselves calibrated by another authentic laboratory. So there is this authentication is done by agencies like NABL, and then you have to have traceability to NABL for instruments that you use for doing your calibration. Then, because you are making a product at the product level, you are not making use of any material that comes in handy, because you have to make use only that which one is going to use again and again in the production. So you have to use the standard parts. You have to have sourcing of parts and materials, and sometimes services. For example, printed circuit boards, you may not make it yourself. So you have to know who makes them, what is the process they follow, and what is the quality that they can deliver. So that is all coming under sourcing or getting suppliers for it. Then you need a quality management system software. You could do without software also, but if you have a management system software, then whatever quality planning you do will be used and will be reproducible without depending on the human errors or human understanding when you go from small batch to bigger batches of the product, and maybe different people who are involved. So you require quality management system software preferably. You require production planning software. You require ERP software, enterprise resource planning, which is mostly required for interfacing the ideas at the commercial level from technical and commercial together. You will require experienced manpower. Many of the tools cannot be used by someone who hasn't learned how to use them, and that comes from experience. So you need experienced manpower. Then you also need information about various standards which are used, which you must comply with. So going to a product level from project is not just a kind of a play of words. It is not just thinking or attitude. It requires good amount of engineering work and with proper tools. And that is why you need to have access to these resources if you want to create a product rather than just a project. Now, in this context, how do we start? How do we plan our work? So I've just noted some of the points from my practical experience about how does one go about planning the work when you are converting an idea or a project into a product. So first you start with a proven concept and early prototype models. So what I'm trying to say is that in your work plan, it is very important that the idea must be proven in some proof of concept model or early prototype model. So do not start from blank and then have to repeat or go through the project phase. For every product, the project phase is required. So it is not something that a product can come out without doing initial work like a project. It is essential, but it is not sufficient. It is necessary, but not sufficient. So you start with a proven concept means you must have already done the proof of concept part or the project part. Then you also do benchmarking of existing similar products. Your project might be indicating some prototype, which is laboratory level proof of concept for, say, a specific product, which is maybe more or less what it should be final. But there are others making similar products. So they have set the standard. They have already given this in some other form. And if you are below that, then nobody is going to look at your product. So you have to study and do benchmarking of the existing similar product. Now, when you do benchmarking, you will do it like a functioning product. Like suppose let's say ceiling fan we have designed as a project, and now we want to make it into a product. We will look at Usha ceiling fan and some other ceiling fan, and maybe we'll get one or two pieces or study them. We can study the functionality of it, but that is not enough. You have to get into internal structure of the construction of the product. So that I'm calling as a reverse engineering. This reverse engineering of existing products will help you to understand some of the things which are not clear at the project level, which, say for example, there might be some small mechanical parts which are required for having certain strength in a product, which you may not have taken care of at the project level. So this you will come to know when you look at what others have done. Invariably, you will find that you may also need to add those things or must have sufficient reason for excluding them if you have come out with an innovation or something which is different than the others. But it always helps to do reverse engineering. That is breaking open a product into sub-products and sub-products into sub-sub-products right down to the level of material. So entire finished product will be finally brought down to level of small materials and objects fitting into each other to make that product. So you have to be able to create a structured model like this. Then you have to now imagine that even though at the project level you haven't got all the internal parts in place, some of them may have to be added at this stage because they are required in making a product which will be robust, which will stand on its own, which will be functional. And then you have to do detailed CAD models for new product for all parts in entire bill of material. Bill of material is a list of materials which go into making a product. So it is listed by assemblies, then sub-assemblies, and then components or materials. So these all, each row in that, each item is an entity, is an object which is there inside the product somehow. Now, each of those have certain shape, size, properties, color. So you have to capture that and have detailed CAD models, computer-aided design models for the parts as well as for the sub-assemblies and the product as a whole. You have
Ashok,
to
sir.
study the standards and then.
Hello.
Hello.
Sorry for interrupt you. When we should apply the reverse engineering?
As early as possible when the basic concept is clear to you. Say, for example, let us take an example of say ceiling fan. We have done a prototype of a ceiling fan by using BLDC motor and then it is rotating, the blades are there, and it is hung on something, and then it does give air. But when you look at the finished product of a ceiling fan, as it is sold in the market, you will realize that there are some other things which you never imagined that they are required in a product. For example, there may be 2 screws given for fixing the fan on the ceiling. There might be a hook. There might be thermocol packings, which are part of a product for carrying that product. There might be plastic covers. There might be some additional supporting parts for fixing the blades. There might be some other features which you never thought of. And that is why when you buy a product, when you examine an existing product, you get the whole thing. And it is there, it is being sold in the market. People are buying it. So there's a value to it. At the project level, you may not have all those things inside. So reverse engineering will tell you that, oh, I have to do this. Oh, this should be there. And then that will help in planning your work. So you should do it at an early phase.
That means it is like to a fragmentation. That means a whole big task will be divided into the some smaller parts.
Correct. And in a systematic manner.
Yeah.
In a very systematic manner. For example, let us say we have to make this table lamp.
Yeah.
Okay.
Yeah. Got
so
it.
Maybe this is in say 4 parts.
Yeah.
A base,
Yes.
wire,
Yeah.
or this
Stand,
stand, and a
lamp.
lamp cover, lamp shed.
Yeah.
So this you name as A, B, C.
Yeah.
Then you take A part, base. Then that base consists of this cover, the bottom,
Yeah.
and maybe some other things. So you would call them as A1, A2, A3.
Yeah.
Then you take A1.
Yes.
Say A2 is a switch.
Yes.
So take the switch and then divide it further into A1A, A1B, A1C. So at every alternating stage, if you change the numbering from alpha to numeric, it gives you very systematic assembly part number. So the entire structure is, even if it is a list, by looking at the assembly part number, you know where that part is fitting. So
yeah,
I call it as APN, assembly part number, and it has alpha and numeric in alternating manner. So if you have A1C5D, that means it is dth part of A1C5. That means it is the 5th part of A1C. C is ABC, cth part of A1, and 1 is the first part of A. So the parent-child relationship become clear from alternating numbers, alphas and numbers, alphas and numbers. Alpha automatically distinguishes the levels. Okay.
That means we have to, when we have to apply the reverse engineering, we have some specific meaningful content, and they have relationship with each other, right?
The only relationship is mother-child.
Yeah.
Something belongs to something. That's it.
Yeah. Okay. Got it.
It is hierarchical.
Yeah.
You go from the whole to parts, subparts, then sub-subparts, then sub-sub-subparts, and right down. At the end, there is only material.
Root and branching concept, right?
Yeah, but there are multiple levels.
Yeah. Got it.
When you are making a reverse engineering and disassembling, it is very simple. You don't need to look at the functions. You don't need to understand anything. You just have to physically separate. This is something a child learns very almost immediately. As soon as you give toy in the hand, the first thing it will try to do is break it.
Got it. Thanks.
Because that's a very essential way in which we interact with the things.
Yes.
We break open so that we understand. And this is very important stage.
Yeah.
So this should be taught right in the first year itself. Then you will see that many projects will be much easier, and project to product transformation also will be very easy, because people would understand the totality of a product by doing reverse engineering of an existing complex product. Okay. Then each part which goes in making assembly and the sub-assemblies themselves, they all, fortunately today, computer models are very cheap. You don't need any money for it. You have a computer already. There are open source free softwares for the computer design. So you can create a replica. You can actually create a model which looks exactly as a real model will look like, real product will look like. So there is no excuse in not having the CAD models done. Whether you are electrical engineer, electronic engineer, civil or mechanical, you must learn mechanical CAD and do actual computer-aided design model of 3D model of everything. It is not very difficult. Okay, but that brings in a lot of clarity. It brings in the possibility of parts not fitting into each other. It brings in ability to analyze it without actually physically making it, because by looking at the CAD shape and doing the CAD engineering on that, you can do the calculation automatically. The computer can tell you this part will break under this load. So you do finite element analysis or whichever analysis. And these tools, because you are going to, everybody is going to finally make a real product. These are essential tools. They are not just part of mechanical engineering. Students today must learn them. Then you do study of standards and compliance for each part or sub-assembly. For example, what is standard? In India, the products, electrical products have to comply with certain Indian standards, BIS, for safety, for convenience, for say, if the product is going to be connected to human body, then it should be non-poisonous. It should not harm the human body. If it is a food product, then it must comply with the food quality requirements. So there are standards of quality, and you have to check whether each part is compliant to the respective corresponding standard to which it must comply. So that you have to do as a part of work. This is a lot of work because you have to go through all parts of your product, small sub parts, even the materials. So for example, if the product is going to go in automotive and there is a plastic part being used there, it is supposed to be not flammable. That means in case of fire, in case of higher temperature, it should not result into flame and aggravate the fire. So there are standards for such material and there are methods for inspecting, and there is information available from the material supplier about whether this material is V1 grade or V0 grade for the flammability criteria. So the different properties have different standards. So if you are using electronic parts which will go in automotive electronics, then they may look alike, but one part may be not allowed to be used in automotive. The other would be allowed because that part is as per AIS say 123, which specifies the maximum temperature at which that part must function. Whereas other industrial parts which are non-automotive grade, they may not work at those temperatures, like 125 degrees centigrade, a part must work if it is automotive. So these are all standards. Then you have to start working on the quality plans for inspection of each part. So how do you check whether the part is good or bad part? By inspecting it. And you have to inspect as per the quality plan, quality control plan, which is a checklist of what is to be measured or observed and what is expected when you do measurements and what is the tolerance in that. Then you have to prepare process plan. A process of assembling or manufacturing has to be documented. Then procurement and fabrication of production tools, like tools and dies I was telling you, or Gerber files, or whichever things that you use as a tool, you don't put that into the product, but you use it as a part of process of making that product. So you have to obtain those. You have to procure them, or many special tools may have to be fabricated. So nobody may be making it. You have to make them yourselves. Then first part, production and quality control. So you have to make the first part. One part you have to make, and then you have to check the quality of that. So that ensures that you have actually gone through all the documented things and followed that document to produce something, and it is exactly what you are expecting it to be. This is very important step in the product. First article inspection or first part inspection. Then there is a pilot batch production and testing. So you carry out, say, 10 numbers or 25 numbers production similar to each other, and then see if there is any variance coming, whether all things are not coming out to be identical because of certain variations in the process itself or the tool itself. So you have to do batch production and testing. And finally, you prepare a final documentation for based on the measurement, based on the quality plans and the production process plans. You produce a documentation for production, produce a documentation for users, and for the service provider. So this is a general work planning that you do when you are making a project into a product. And as I said, you use these resources for making these final outcomes in the work plan, one after the other. So I think this is a basic thing which I wanted to explain. Now, when you take any specific example for converting a project into a product, you can understand whatever points are listed here, and then you can refer to them. And first of all, you have to learn to utilize those resources and understand whether you are creating the right kind of documentation. Again, for this also reverse engineering is useful. Reverse engineering of a product structure that I explained. But looking at the existing product documentation, manuals, say if you get access to some technology documents, which is very difficult. Usually these are very secret documents or expensive documents, and you may not have access to them. But in case you get access for some open source hardware technology, which may be available, or if you go to some industry and then get to see these documents, please see them, especially in automotive product. If you go, you will find very good quality of documentation. So that is also a reverse learning from existing things done by bigger companies or multinational companies. You learn. So by looking at the documentation that goes along with it, many times this documentation may be available freely downloadable on the internet. Try to get access to that and understand and follow those methods or those formats or templates. Any questions? So do you have any questions? Anybody? Hello, am I audible?
Yeah. Audible.
Yes, sir. Yes, sir. Audible.
So if there are any questions, let me know.
If anyone having question, please ask.
सगळं समजलं का मी सांगितलेलं?
हो सर, हो.
थोडक्यात सांगितलं, पण हे महत्वाच्या गोष्टी आहेत या. आणि तुमच्या सोबत एक काम करायला आवडेल एखाद्या प्रोजेक्टच्या बाबतीमध्ये, म्हणजे मग आपल्याला ते प्रत्यक्ष अनुभवायला मिळेल.
त्यातले जे बरेच पॉइंट आहेत ते ऍज पर्स्पेक्टिव्ह टू एनी प्रोडक्ट रिलेटेड प्लॅनिंग और एनी प्रोडक्ट रिलेटेड डिझायनिंग. the all points should be very important. Because without this proper planning or without this applying methodology, we cannot design any products. So it's a very helpful and that means good content.
See, I have given this PPT, just a small, this is not a full PPT, just a note to Mane sir on the WhatsApp. So you may distribute it to others.
Sure.
I'm sorry for the initial problems. Unfortunately, there were some memory issues in the laptop, so there were some difficulties I faced. Do you want anything more? Anything more you would like to know? Typically, let me tell you, if we want anybody wants to manufacture a product. For example, just the other day, somebody was saying that there is a industrialist who has money and he is supplying boxes to make the electric vehicle charger to somebody. And then he is thinking that why not make the entire charger ourselves for selling it to the vehicle manufacturer. But he doesn't know how to make it. There are many people who earn a lot of money. Let's say a builder is earning a lot of money, but he is all the time buying the parts, then making a project and delivering the houses. He may get up thinking that, look, I buy so much of brass hinges for doors, and my purchase bill is almost running into tens of lakhs. And if I measure the weight of the brass, then per kilo, the brass is, let us say, 200 rupees a kilo, and I end up paying for the hinges something like 500 rupees a kilo. So that means one can understand that there is a good value there. There is a good margin available there. Then he might say, I want to make the brass hinges. Then what does he need? He needs this. He needs all the documents. He needs all the standards. He needs to have dimensions. He needs to have quality control. He needs to understand the process. He must have tools, machines, and the dies. And he must have trained manpower or must be able to provide the training, and then have the entire thing which goes in making those hinges as a product. This is called technology. Technology is not just a description or a concept or a name or a word. Technology is collection of all these things which I have listed here. And if somebody buys, let's say, technology in terms of documentation and prototypes and tools, then using that, suppose he makes 100,000 pieces. Okay. Every piece generates some profit. So suppose he has paid, say, 10 lakh rupees for the technology and he's going to make 100,000. So per product cost of that technology is only 10 rupees. And the product itself may be costing something like 1,000 rupees. So he will say, good, no problem. I'll give 10 lakh rupees, but get this documentation, get all the samples, get all the tools, and start my production. I will recover my cost of 10 lakh rupees over 1 lakh products by adding only 10 rupees per piece into the price. Usually, cost of technology is considered to be of the order of 2 to 5% of the production cost or the revenue. So if you want to sell the technology, if you develop this technology or you develop a product from a college, I tell you there is a demand, because there are people with money, they have desire to produce some things, they don't know how to do it. And you cannot just describe it to them. You cannot simply show them a lab prototype, because then there are many things that they will not be having in their hands, and they will have to learn in hard way by making mistakes, and it is too expensive. So they would therefore many times what people do, they invest money in only trading. They go to China, buy the product, or they get CKD product, knockdown kit, completely knocked down, that is CKD, and assemble the product. Or they look at collaboration. As a part of collaboration, foreign company gives the technical know-how or technology to them. And what do they give in that technology? They give exactly what I've asked, what we have discussed today. So if colleges start giving technology to the people around, then the college is doing what they're supposed to be doing in terms of strengthening the technology, strengthening the capabilities of the society to be able to make in India. Otherwise not. So it is very important aspect that educational institutions must keep in mind. In absence of that, the startups without any experience, they have fire in their belly, they have ideas and they would like to struggle, but they do have to do a lot of struggle, and they don't have enough funds also for doing that. Sometimes they waste a lot of money. Sometimes they fail miserably, because developing a technology, as we have seen, requires many resources, many methods, many manpower with experience. This is available only in institutions like colleges. It is also available in somebody else's company because he has learned hardware. He has now experience. He has people who can do design, documentation, but then he does it for himself. There are very few companies or agencies which do design and technology development for the sake of development for others. This is called contract R&D, contract development. So if you do contract development, you can earn royalty. It is creative work. It can earn high value without physically doing anything further. If the technology is good and if people can use it, it can keep on producing value, and you can simply keep on getting the royalty on that. Or at one time, you might get much more money than what it costed you in developing that technology. So technology has got a very high value. Many countries, when they go up the value chain, like in USA, the design, the detailed design is done by Indians, production is done by Chinese. Worldwide distribution, marketing, and the initial concept design and the entire business is done by Americans. So they make maximum money, but they do invest a lot of money. So this, in the entire cycle of technology development, production, and consumption, technology development is a very, very, very important contribution that one can make. And education institutions are ideally placed for doing that, and government gives a lot of technology funding also to such institutions. They don't give that funding to industry because if it doesn't work, if the industry doesn't use it for what it is intended to be and just misuses it, then it is just a loss. So education institutions, especially a faculty like you, must get into this to convert projects into products. Thank you. Sorry for duplicating it, but another 10 minutes again. Is that if there are no questions, then we can stop now. Thank you very much, and I hope to see you tomorrow.
Participant, if anyone have a question, please ask. Hello? Hello?
Yeah.
Sir, if any question, please ask. Sir has completed.
Yeah. From my perspective, it's okay.
Yes, sir. Yes, sir. Yes. Okay, then. If there is no question, then as a coordinator, I conclude that our today's session has ended. Thank you, Ashok Saraf sir, giving such a wonderful guidance to our faculty members.
Thank you very
sir.
much.
Thank you.
Thank you, Mr.
Yes.
Professor Manik.
Yes, yes.
All
Thank
the
you, sir.
best. See you tomorrow.
Yes, sir. Yes, sir. Thank you, sir. Okay.
Thank you.
Ashok sir,
Yeah,
thanks for your experience you have to be share here, and we gain the lot of knowledge regarding to your experience. So this is very helpful, and once again, thank you.
thank you, thank you. How do I close this?
Okay, sir. Then
Thank you.
Yes, yes.
I am unable to close this on the laptop. I normally use on mobile. Alak, can you show me how to bring up the full screen? I don't see the button to close it. Yeah. Yeah,